So, welcome everybody. Thank you for coming. We're going to talk about Swift. So, it's a good time to ask, what are you doing with Swift? Do you guys have any experience with Swift? Here, let me give you the good news straight away. Do you guys have experience with C#? Awesome, you have a lot of experience with Swift. So they're very, very similar actually, which is a really good thing. So most of you have not done very much with Swift. How about with Objective-C? A little bit, a couple of you guys looked at it, said, yikes, that's yucky, let me get out of here. Yeah, it's definitely a different language, Objective-C is, than what most of the common languages are. So Swift is really a nice sort of reset from Apple around that whole language space. Right? You'll see that this is really meant to be the new language to program Apple devices, all the way from way down at the watch level up to like the super high-end, Mac Pro little cylinder thing, right? All of the types of apps you want to write, iOS and OS X. Okay. So my name is Michael Kennedy. I work at Developmentor. You can find me on Twitter, places like that. These slides should be up there for you to get. Okay, so let's talk for a little bit about what is Swift, what are some of its inspirations, where did it come from, and so on. Then we'll go to writing some code about it. So this is pretty blurry. Let me see if I can change the display really quick and make that better for you guys. I think it's, if I scale it, yeah, that's pretty bad. I guess we got to do that. We're not going to be able to use 800 by 600. So we got to stick with it. Sorry, folks. Okay, back we go. All right, so here's what I would define Swift to be. This is a modern. Come on back. There. Swift is a modern, safe, and powerful language meant to be the new foundation for building apps for Apple's platforms, iOS and OS X. I think this is very similar to what we saw when .NET came out for Windows. You guys remember what was before .NET, right? That was a while ago. But there was a time before, and it was painful. There was basically two choices. You could either decide to go with the somewhat easy, but usually not going to work that well for you, VB route, or you could say, fine, I'll write C++. Right? And it's kind of how it is right now with Apple. You could say, well, I could use PhoneCap, Cordova type stuff, or I could do Objective-C. Now, notwithstanding the excellent work the guys at Xamarin are doing there, Mark. So, Mark is from Xamarin. So Xamarin is another option, but this is, that's kind of a side conversation, right? Xamarin lets you write C# code. But if you're going to stick with what Apple provides, or, you basically have to use Objective-C. So this is a really refreshing thing to have a new language. And when they introduced it, they said there's been three major motivations and pillars of this language that we're going to build. They said this language is safe, unlike C, or think of where they're coming from. It's modern. It's not 25 years old and kind of funky even when it was new. And yet it's really powerful. It's not like VB in the sense that it's really easy to use, but it doesn't do so much. All right, so what does that mean? Well, there's a bunch of parts to it. It doesn't allow you to use direct pointers. Come on in. It doesn't allow you to use direct pointers. This is very much like C#, Java, Python, and so on. It deeply embraces the concept of immutability, right? And think if you guys have done C++ or something like the const keyword. In .NET, it's not really a big meaning, right? It just means the thing can't change. But C++, the const can kind of propagate through function calls and so on. Here, there's some really powerful ways in which you can leverage this concept of like a constant, immutable, read-only type. And it could go through like an entire object graph, not just the pointer. Right? Like C#, the conditionals that you work with, they have to be a true or a false thing. It's not like if number, do something, right? It's number is 0, then it's false, and it's non-zero, it's true. There's none of that in this language, right? So very strong conditional checking. It has strong typing. This is a statically typed language. So just like C#, it has generics, strong typing, interfaces, It has structures and classes for value types and reference types and so on. So that's cool. So that's kind of the safe part. The modern part is you'll see it as a really concise syntax. And there'll be a lot of things to like here. For example, in C#, to create a read-only property, you've got to say all the property stuff, and then you've got to have a parenthesis, and you've got to say get, and you've got to have a parenthesis, and then you write the parts. And you maybe need an underlying member variable. Like you'll see in Swift, there's a whole lot less of that you write. It can assume the get in a read-only, and you can like drop a bunch of the curly braces. Similarly, while loops, for loops, if statements, none of them have parentheses around them. You can write them if you want, and they'll be ignored. If that makes you like feel more comfortable, right? Like, oh, I love parentheses. But you don't have to put them there. That's cool. They've got closures, think lambdas, generics. It supports type inference. Very, very much the same way that C# lets you use the var keyword. You say var something equals a thing, and the compiler goes, oh, this thing is a customer object. So boom, var means customer. Same thing here. Okay. So that's very nice. It's type inference. They have what's called a REPL. You guys know what a REPL is? Read, eval, print loop. It's like a dynamic sort of scripting environment where you can like type stuff and try things and then type something else. It's kind of a command line to your app, if you will. Very much object-oriented. So very modern in that sense. And it's also powerful. It lets you return multiple parameters from a function by taking basically tuples and compressing them in one thing and then decompressing them or decomposing them on the other side. It has operator overloading that's super easy. It has this concept of basically the same idea as interfaces with protocols, and as well, it also has this concept of extension methods, so you can sort of do a lot of stuff there. It has this playgrounds. You guys know playgrounds? Yeah, so playgrounds are like a cool sort of UI scripting dynamic type of way to work with this strongly compiled code. Okay, so they've done a lot to make it feel like a scripting language. So if you know very much about Python, you'll see this is highly, highly inspired by Python. Keywords, function names, many, many things. However, it's compiled, right? It's also highly inspired by C#, according to the guys who built it. All right, speaking of guys who built it, that guy built it. There wasn't like a committee that got together and said, oh, we're old and outdated here at Apple. People hate our language, but somehow they keep building for it because they can build such amazing things on these platforms. And that's so true. This guy, he was in charge of the compilers at Apple. This thing called the Llvm Compiler that is involved in Objective-C compilation, and it's actually a much broader research project that him and another guy started at Champaign-Urbana in Illinois, the US, as a grad student, and he went on to sort of bring that knowledge to Apple. So there's a really interesting article, and you can click on this link and pull it up in Wired that details the history of Swift when it first came out. So it says, in the summer of 2010, Chris Latner, this guy, spent 1.5 years creating this language. And he said, what I need to do is create something that's modern and powerful and might be the next generation for what Apple's doing. And he didn't tell anybody. He just said, you know what, I'm going to go home from work and I'm going to do this. Didn't get okay from the boss. This is not like a thing that Apple sponsored. He's just like, what we're doing is crappy. We need it to be better. So I'm going to go build this. And it spent 1.5 years on it. He took it to the guys at Apple and said, hey guys, guess what I've been up to? Check this out. This is cool. And they're like, you're right. This is cool. This is going to be the new thing. And they gave him a team of people to start working on it, right? So mid-2010 it started, and it was released at WWDC in 2014. So that's another 2.5 years of work that they put into it afterwards, all right? So it started as this skunkworks project in 2010, got released sort of as a preview in June 6, 2014, and it was released in September last year as a proper thing. Came out basically with Yosemite, the Yosemite release, okay? So if you look at that article, it's an article, I think it's the article, maybe his webpage. By the way, you think Apple, he looks like a pretty hip guy. He's probably got this beautiful website. His website is not beautiful. It's got information on it, but it's like, this is the website a guy who writes compilers would make. But it's still got great information. And one of the things he said on there is, it was highly inspired by basically 3 languages and then some others. Objective-C, of course, because it was meant to replace Objective-C, and it uses the same runtime, which is interesting. It's highly inspired by Python, as you will see. and C#. Okay? And some others, Rust, Haskell, and so on. But I think those three show through the most. All right. There's this book. If you own an iThing, you can get it for free. Just go to iBooks and download it. So this is in the iTunes bookstore. What's remarkable about this is not just that there's a free book about the language. That's not super remarkable. What's remarkable is it was downloaded 370,000 times within 24 hours of its being available. That tells you there's a lot of interest in this language. Swift is the fastest growing programming language in history. So it went from like off the map to number 22 in like 2 months of it being announced or something like that. Because the alternative was so bad before that, whew, hey, we love this, we want this. All right, so very interesting. So why might that be? Some of you raised your hand, said, I know Objective-C, I've checked it out a little bit. Here are two ways to do the same thing. In Objective-C or Swift. Here what we're doing is we're creating an array and we're appending an item to it, the number 10. I guess in the top part I have a variable called number. Well, yeah, okay. So we could either just say array equals float bracket, or we could even shorten that a little bit. Or you could say ns mutable array star array is first you call this alloc function, and then you call the init function, then you alloc a number, and then you can insert them. Like, there's a reason that this is painful to do, right? And this is not. Okay. So it was time for some kind of replacement, and Swift is doing a really good job of that. Now, Swift uses type inference. This is kind of a new idea, but most of you guys know C#, so this is not a new idea to you, right? So we can come over here and we can say var array equals, some array here, we're declaring an array, and put doubles in here. It sees, all right, here's an array, and the thing that goes inside there is doubles, so that must be an array of doubles. So it's a strongly typed array, which is a generic of doubles. And here's a string, because the thing on the right is a string. And here this function returns some number. It says an int, so that means sum is an int. Right? You can explicitly say the type, but you don't have to. All right? And this is very common. Okay, so you can imagine we would use Xcode to write some apps, and we're going to stop in a minute and write some code, don't worry. So you can imagine Xcode must support Swift, right? Xcode is the main, it's like the Visual Studio from Apple, right? That's the way you've worked with Objective-C for so long, and that's how you work with Swift as well. And you'll see it has really, really good support for that. However, there's also other IDEs, right? If you guys ever wished that the people that make ReSharper would make a standalone Visual Studio that had nothing to do with Visual Studio, yes, I have. Well, they did one for Apple, right? So AppCode is another IDE that you can use to do this as well. Now the truth is, this is really good for working with code. It's kind of crummy for working with UI stuff. When you really need to do the UI bits, I would say flip over here and just do it in the storyboards and stuff. Here, if you're just going to get into the code and write some code, it actually, the code editing manipulation pieces are better here. All right, so let's go write a little bit of code here. And we'll use Xcode, which is here, get in the middle. So what I'd like to do for you guys is first create a really simple playground. We'll play with the playground. It even tells us to do that. And then after that, we'll write like a little somewhat involved game, right? Not super involved, but enough that it's like non-trivial. So when you get started, you come down here, it says, well, what do you want to do? You can say, I would like to create a new playground. I would like to make it a little quieter. Or you can say, I want to create a new app, a new proper app. So close to keeping it cool. Okay, I can either create like a full-on app, or I could create this playground. So we'll start by creating a playground, because there's some really interesting stuff that you can do here. So let's zoom up for a minute. So it says when you create this playground, there's two things to do. You give it a name, and you pick your platform. Do you want to play with iOS APIs, or do you want to play with OS X APIs? Right? They're similar, but they're not the same. So there's Cocoa, and there's Cocoa Touch. Let's, eeny, meeny, miny, moe, let's go with this one. Doesn't matter. So we'll say sample first playground. Okay. And then it says, all right, well, where do you want to save it? Let's put this, everything over there. No, we'll put it there for now. Oh, but let me make a new folder. And then we'll put it down here. So call save. And then there we have our playground. So let me try to make this fit a little bit better just for the screen for you guys. Maybe that'll work. Okay. Stay, don't go across the monitor. All right, so it's cool, it comes up and it even tells you this is the place that people can play. And you can just do stuff here. I don't know if you'll see, maybe I gotta move this up a little so you can see. Yeah. So if I come down here, I can say str dot uppercase string or something like that. And for a second, you can see it spin. You'll see it spin down here, then out comes an answer. So it's a little bit like LinkPad or some of these other kind of free-form areas where you can just do stuff. So I can show you a little bit about the language here. So maybe I want to have a set of numbers, and that's going to be an array. And maybe we want to put a bunch of numbers in here. Depending on how geeky you are, you'll definitely recognize them. I suspect everyone recognizes them. And then we can do certain things with them. So I could come around here and I could print them out. So watch this. I could say for var I equals, you're probably doing it wrong at this point. Right. If I wanted to go through that set in C#, how would you do it? Link, yes, yeah, but if I wanted to use a loop to go through it, but you're right, link.
For each.
But exactly, for each. So I would say for each over here. All right, let's try that. Darn, misspelled it. No, still not working. So there's only a for loop, but there's a cool variation called a for in loop. So I can write that, and that's the for each loop. They just don't use a separate keyword. Okay? Which, by the way, is identical to Python. Okay, so if you come over here, they still use parentheses, and just notice the editor. I'll go over here and I'll type that, and if I hit enter, it's like, okay, since you sort of decided you're going to use that, I'll close it off for you. It's not as good as app code, but it's not bad. So I can come down here, and I can just restate this here. If it runs, it says, oh, look, 8 times something happened, and there was some sort of value here. So you go, okay, that's kind of cool. What happened? And it says, those are actually the numbers that were output there. Isn't that slick? You can put animations and you can capture stuff in time, and there's all kinds of really awesomeness that you can do over here. So if you're doing like scientific computing and you wanted to show people stuff, this might be a really nice way to do it. It's not the only way. There's R and there's IPython and all sorts of stuff, but this is cool. So I could even do n times n minus 200, or whatever I want to put here, and I can look at that and see minus 200 up to whatever that is, right? The square. Whoops. Okay. And we can also, maybe that's not what we want. We want to print it out. We say print, and we could just say the number is, and then we can go over here. This would totally rock in .NET, right? I could write this. You would say console write line, but now it turns out we have this little red sign that says we're not so happy with this. There's a missing argument for this number 2 in the call. That's odd. So the error messages are bizarre, but we kind of need to make this a string. Now it's okay. So cannot convert automatically implicitly to a string means there is an argument missing for number 2. Whatever. But the outcome is over here, we now actually have no results anymore for that little loop a couple times here, but then you get this string output. And if you're like, I don't care about this or this, close those. Oh, here's actually, with the console, I don't care about this print statement. So you can actually, hide and show some of these pieces. Okay, pretty cool. There's another way to do this in Swift. And by the way, it's very C-sharpish based, so like the comments and so on are there. That's cool. There's another way to do this. If this was console write line, I could say this. I could say the number is, and I'd do like a curly, and I put a number here. If it were Python, I could just leave that off. Then I would pass n to it. Yeah. They don't do that here, but there's something you can do called string interpolation, where you can sort of say, here goes a variable, and you do that with a backslash and parentheses. So here's n. Okay. Okay, and then if we go back, let's say the string, the number is this, and I'll put 3 exclamation marks just so you can see like that there is something different. Okay, so this is kind of the string format variation that you guys have to work with. There's other ways that are more C-based, like remember sprintf. Does that mean something to you guys? Going back, yeah, like with %s and %f, and you know, that's still useful here. But you also have the string interpolation thing, which is nice. Let's look a little bit at functions. So maybe I want to have a function here. Maybe I would like a function that returns this number or something like that. So let's come over here and say this will be get numbers, something like this. So I'm going to define a function. Things are a little reversed from the way they are in C# or a lot of the C-based languages for functions. So it all starts out with saying func something. So I'm defining a function. Then you say the name of the functions like get numbers. Then the parameters. We don't have any parameters yet. And then you say the return value is an integer of an integer array. If this were C#, I would write this. It's not. So I write this. All right, that's how you say an array of integers. Or more properly in your mind, think as a list of int, sort of, because you can add to it. Okay, so then we just do some of this action, return the nums, and off it goes. Okay, so then you can come up here and you can see that the playground actually captured these values as they were returned from there. And if we called it multiple times, kind of like we are here, you would have like the history of the different calls that were made to that function. So if I do this again, get name socket or numbers, I'll take either. Yeah, it's all good. You can see that this now says 2 times because it was executed several times. And you can get this little pop-up, super helpful. It says 2 times, in case you didn't see it there. No, this is really actually helpful if you're working with UI widgets. If I created a button dynamically here, the button would actually, the UI representation of the button would show there. If I created like a data grid, literally the picture of the data grid, and if I created the data grid, then added some items and changed its color, there'd be 3 snapshots of first an empty data grid, then the data grid with no styles, and then the style data grid. It's pretty awesome. Okay. So this is a cool thing. It's not really meant to kind of be where you write real applications, but it's a cool way to explore, right? You can do animations. At the Apple event, they showed like a timeline with like little game playing up here, and you could actually play the game and then reverse it back in time to like see how the game was as it went through it. And so it was pretty cool stuff you can do there. Let's see. Let's do one more thing. Let's take the numbers and let's add a parameter here. So let's suppose I want to add some value. I'm just going to multiply all these numbers by. So if I want to pass in an n, I'll just, this is really quick here, we'll just do something like this. It's totally cheesy, but it'll work. So if I wanted to pass in an integer n, you might think I would write int n. That would be your C# showing through. You write n:\int. You said a lot of stuff is kind of reversed. So here, not just in arguments, but throughout the language, you say variable : type. Right. So now if I go up here, this is not going to work so well because this should be 5 and 11. You can see the output. And then, of course, down here, you can see, where did it go? Down, down, down. Those are the variable, or the state of that function the 2 times it was called. First when it was called with 5, and then it was called with 11. So that's kind of a cool historical debugging type of thing as well. All right. How are we doing on time? Good. Back. So this is kind of a cool thing. This assuming it's not really doing it, is it? So this is kind of a cool thing, and it's meant to like kind of play around here. This says there's something going on. I don't think it's a problem anymore, is there? Yeah, don't worry about those errors. The error handling is a little weird. There's some odd stuff in the language where it's not quite as forgiving, or the error messages like you saw when it couldn't convert to a string, it didn't say can't convert to a string, it just said like this thing number 2 is wrong. Stuff like that, which I suppose it was speaking about the second parameter to the plus operator. Okay, so let's go back to the slides for just a moment. So we can choose, if I move my hyperdoc out of the way, we can choose Playground, or we can choose a new Xcode project. And if we choose a new Xcode project, we can create all these different types of apps, right? So you can create sort of top-level applications, which are the first 5, single view app, which is the most simple, master detail, page-based, tab-based, or you can build in like lower-level things like a Cocoa Touch framework, which is a library you might reuse across other iPhone apps. Or you can even build in in-app purchase. Okay. What's also really cool is you can use this to build OS X apps. Okay. So I can build a command line app, like a windowed app, basically the equivalent of like a WPF app or something to that effect, or a library, a Cocoa framework library. Right. So a lot of things you can do. All right. So we talked about these playgrounds. They're really good for just experimenting. They're also very good for algorithm development. So if you guys are building algorithms and you need to visualize some sort of data, you saw those little graphs are super helpful for that. If you're teaching, it might be good for this. If, like if you're teaching kids programming or somebody who's like not really a programmer, they might be more comfortable in that space. You never saw a compilation step. You never saw any of those type of things. However, this is just as compiled as a C program, right? So behind the scenes, there's lots of like native compilation going on. But it makes it feel just like maybe Python or Ruby or something like that. And here's the one they showed at Apple where they have this little game going around and there's like a balloon flying around and they're shooting at it. And this was all going live. You could sort of zoom forwards and back forwards. So you write code over here and it shows you just kind of like a little debugging output over there, and then you actually have this visualization assistant editor type thing here. Right, so that comes with Xcode. There's nothing you have to do. You also get what's called a REPL, read, value, print loop. Right? So I can come over here and I can type xcrun space Swift, and then I get this place where I can just start typing, and it kind of just builds up. It's a little like if you hate UIs but you want the same experience as you got with the playground, you can do that here, right? So if you come from a background like heavily in Linux and you're super into command lines, this might make you super happy, right? This is of limited use given the fact that playgrounds exist. Another thing though that you can do with this that is not of limited use, that is actually awesome, is you can put what's called a shebang, hash bang, and then an environmental setting here, so user bin xcrun, and give it the command Swift, and then this is the text of the Swift file, and this becomes just a thing that you can run without compiling, just like a shell script of some sort. And if you're not familiar with shell scripts, think batch file, right? There's no compiling this or anything. I just type this in a text file, and then I just make it go. Now, it turns out the very first time you make it go, it's slow, because it compiles behind the scenes, and then it goes fast. But it caches it somewhere, I don't know where. And then there's a little note that you may need to make the file executable. I believe in OS X it's not executable by default, so you have to say change mod a+x file name. All right. So one of the interesting choices they made, and it's interesting in both a good and bad way. An interesting choice they made is this uses the identical runtime as Objective-C. So what that means is I can write some code in Swift and hand it to somebody who does not necessarily have, quote, support for Swift, and it'll just run. Right? It'll run on iOS that doesn't necessarily have some kind of runtime. It's not like .NET or Java, where you've got to have the runtime, and oh, sorry, you've got .NET 1, we have .NET 2 now, you're going to go download that. None of that happens, right? So there's no compatibility issues, right? You just say, here's my compiled output, run it. You're an iOS or OS X thing, go. That's awesome. What's kind of less awesome is they didn't take advantage of the ability to build in like a richer, more modern set of underlying APIs. Right? All you could do in Objective-C or whatever is kind of the libraries you get to work with here, right? Like one of the things that was really cool when .NET came out was all the XML processing was built in, and the string processing, and all the stuff like kind of above Win32. Think of this as like kind of the same as C# compiling to Win32 and nothing in the middle. There's no .NET framework, right? So for better or worse, it's great because adoption is no problem. We can all do that. It's not so great because they didn't really take the chance to modernize the API as much as they could. One thing that's interesting is this looks like a much more high-level language compared to Objective-C, which is a very C-based language. However, they claim that it's actually faster in non-trivial situations. Right? And the reason is, when you're doing stuff in Objective-C, here's sort of the tooling pipeline. You write your code, it gets parsed by this Clang. This is all part of the Llvm Compiler stuff that Chris Latner worked on. And then it gets compiled down using LLVM into like some low-level code, and out comes machine code. And they were able, because you're saying less, to change what you mean more by doing optimizations in the compiler. So they claim things like several times performance improvement in some cases over the native Objective-C stuff, which is pretty cool. It uses reference counting. Is reference counting good or is reference counting bad? What?
Great.
It's great for performance. What is the Achilles heel of reference counting? What is the curse? Cycles, absolutely. So Java and .NET don't have this problem because they find stuff that is not dead. They don't find stuff that is dead. They just find stuff that's not dead and go, well, whatever else it was, poof, that's dead, right? They mark the valid stuff, the generational mark and sweep garbage collectors. COM, which predated .NET, used reference counting, and it was bad. It was bad because there were cycles, and the cycles meant memory leaks, and so you just kind of sucked it up and dealt with it somehow. Over here, they've actually added special language keywords, and you'll see them right away when you try to build an iOS app. Things like weak and unowned and so on that speak about the relationships of what keeps what alive as a language keyword. So if I have like a button that points to its view and a view which points to the button, that would be a cycle. But when you create the button, you say the button does not own the view. And so when the view goes away, the button goes away. Things like that. So you have to think a little more about it, but you get deterministic, no pauses sort of native code execution, which is a good thing. You have more control over it. Okay, and you also have support for working with Objective-C and C natively. Like, there's nothing basically to do except for include a header. What that means is, if you've got an Objective-C app that you've built for iOS, or found or whatever, inherited some library, or you've got one that's built for OS X, you can just start adding Swift files to it and not upgrade it. Right? You don't have to like convert the entire app. You're just like, well, when I do new stuff, that's going to be Swift now. And I'll try to like, if I got to go change something, maybe that'll get converted to Swift, but there's not a force upgrade to start using this. That's awesome. And it goes both ways. Like, you can pass your Swift object to Objective-C, or your Objective-C object can be used in Swift. It's pretty sweet. They said C++ is the thing that we're not going to like deal with. You can like go down to C, use it, and then come back from C if you want, because we don't do that. All right, so I'll show you some performance stuff, and then we'll go write a little more meaningful code. Then we'll come back and look at a few more slides. So here is an example of showing complex object sort. This is done in Swift, Objective-C, and Python. They use Python as the base because, one, Python is somewhat slow under certain circumstances. I think they pick on it a little too much, but nonetheless. So here's sort of a baseline of Python. Objective-C is only 2.5 times faster, but Swift is actually almost 4 times faster. That's pretty cool. Here's a better example of how much faster Swift is. If we're doing RC4 encryption, Python, if it were written all in the script level, would be 1x. Objective-C would be 127. This would be 220. So one of the big trade-offs that you think, if you think back to .NET, that we had to make was .NET was so much better than MFC and C++, but it was slower. And remember back in the day, like when you had a Pentium 90 or something like that, you would go run it, and there would be a noticeable difference between running a .NET app and an MFC app. MFC app would come up like that, and the .NET one is like, is it running? Oh, the hard drive's grinding. Yep, here it comes. Poof. And that's still somewhat true with WPF. But, you get this nice new modern language without saying, okay, it's worth being slower so that we can have this more productive space, right? Which is a really nice thing. You don't have to make that argument. All right, language. Let's go talk about the language by looking at one slide and then writing a game. So here's a quick flyover of how things look in this language, really quick. So this should look super familiar to you. This is the var type inference stuff. You say var type equals some var variable equals something over here on the right, and it just goes, okay, that's an int, so var is an int. This is a string, so var is a string, right? That's really easy and straightforward for us. The functions are a little bit different. You say the name and then starts with func, and you say it returns this way. The if statements and while loops and so on are almost the same, except for the parentheses are gone. Right? They really were not needed. If you guys have worked in a language that doesn't have it, and then you come back, you're like, I should not be typing this. I'm so tired of these parentheses. If you've been working only in C and C#, then you're like, what's wrong with parentheses? You'll see. So you don't have to put them there. And then, of course, no semicolons. Okay, good. Should we go write a game? All right, I have a very ambitious game for you. Not so ambitious. So let's switch over here. And you don't really need to adjust the brightness. Hold on. Let's go back to Xcode. And we'll say new project. And here you can see it's asking what type of project do you want. We're going to pick just a basic command line application for a minute. Once we get that working, we'll come back and we'll look at the iOS side of things, okay? So even though I want to make a game, I'm not going to click on game because that's like a real game. This is like a fake demo game. So, right, we'll build out like a text game. So it gives you, let me show you a little better what's going on up here. So it says, what is your product name? What is your company name? What is your org identifier, which is meant to be kind of like your domain, this is our domain written backwards. Very Java-esque here. So the game we're going to create is tic-tac-toe. All right? So very simple. I wanted to create 25-way rock, paper, scissors, but it's just too much. Okay. So then it says, where do you want to put this? I'm going to put this on the desktop, and hopefully there's not something called tic-tac-toe yet. Okay, so we go over here, and this is sort of the settings for your project, and you get just this main file. Let me see what I can do about the fonts here for you guys. Let's make this a little bigger.
You can pick presentation large too.
Yeah? That's all right, I think I got it. So that should be pretty legible. Good? You guys in the back can see okay? All right. So it's cool that we can say hello world. So we can run this, hit Command R, and you can see at the bottom, I know it's a little hard to see, there's that. Okay? But we don't want to do this. We want to build something more fun. Let's build a game. So I'd like to be able to write var game equals game, except there's no such game thing. So I want to build a class that is this game here. Okay? And this is the way you new up objects. You don't use the new keyword. You just say, class name parenthesis, and that's runs the allocation automatically. So let's go and create another variable. So I'll say add new file, and it says, okay, what kind of new file do you want? We want a Swift file. There's probably a Swift class we could choose or something, but we don't need it. We'll call this game. And down here, we could leave my little comment, but I really don't care. It says import foundation. Now foundation is actually a whole set of APIs. If I command click it and I wait, you can see this is actually what import foundation means. All these types, all these extra function definitions, these sort of bare methods and so on. So core foundation is really good, so we import it twice. Then you get core graphics and then so on. No, but so basically when you say import foundation, these are like the standard libraries you're going to need for OS 10. If this was an iOS thing, it would say import UI kit, but similar type of thing for Cocoa Touch. So we're going to create a class. This should make you guys really happy. That looks familiar, right? Yes. Now they've taken a lot, especially in the classes, they've taken a ton of stuff from C#. Right. So let's see, we're going to create a game, and it's going to be a board, a 3x3 board, right? And it's going to have players, an X and an O. It's got to know who's currently playing. So these sound like variables. Now remember over here, the way we create variables is we say var, player equals Jeff. And you can say it this way with type inference. Or what if you wanted to write this? Like, I would say, come down here, let's go like this. Say player, whoops, you say player equals that. Well, the type inference is broken because it's like, well, you didn't, when I got to create the thing, you didn't tell me what it was. So that there's a way you can say the type, instead of like replacing this var like you would in C#, you just say colon string, like this, and now it's happy. It's happy. It says it's not happy, don't believe it, it's fine. Global var requires initialization, blah, 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 don't worry about it. But it doesn't want you to write global code outside of the main script, that's why it's unhappy. It's a little like C# in that there's one area where you can write just standard stuff, and then everywhere else should be in a class or a function or something to this effect. Function would be enough. C# would require a class. But this is the way that you can kind of define these. And so when you go to the class here, you have the same basic idea. You say var board, and I could either allocate the board, or I could just say this is going to be, now I want a two-dimensional thing, so maybe an array that has 3 rows, and each row has 3 integers, which is going to be x, the value for x, or the value for o, okay? So what I'm going to do is I'm going to have an array. Remember, arrays of integers look like this, but I want an array of integers, so it looks like that. Make sense? Okay. So I've got that, and maybe I want a sentinel or a value to indicate that nobody has played somewhere. So I'll say var empty equals 0. And because I'm assigning it here, I don't have to say the type, just like on, but this I'm not allocating yet. I'm going to allocate that in the constructor, so I got to say the type. Make sense? And then I'll have var x equals 1 and var o equals -1. There's all sorts of nice stuff that if you represent things with 1s and -1s, switching players is easy, figure out who won is easy. We're just going to use those numbers because it works out well. Now, if this was C#, I would write this, public game, and that would be a constructor. But this is not all C#. This is like a Python C# baby language. Like if they got together and were merged, what you would get. So in Python, the constructor is called an initializer, and you say init. So here to create a constructor, you actually create what's called an initializer. It can be public, it can be private. There's all sorts of interesting stuff about rules in which you can create convenience initializers that only do part of the job and then delegate down to base classes, and it's quite complex. It's surprisingly complex. The order in which you interact with a superclass, so you would say like super dot init, and you would pass stuff there, and so on. The other way in which this is like a Python sort of variation is, do you guys know what the pointer which points to the object you're within is called in Python? Self. Yeah, it's not this. So self. Self is this in this language, okay? And so you see self.board, empty, and so on. You don't have, like C#, unlike Python, you don't have to say self. Right? You can just say X and it knows what that is, or you can say O or board. But if you want to refer to your individual object, you use the keyword self. So here I want to initialize the board. Let's say board equals, and we're going to create one that is empty. I'm going to do it like this. Empty. All right, so a list of lists, basically. And like C#, you can leave that there if you want. You don't have to, but it's kind of nice if you can add more. We're never, ever going to add more. We're done. Okay, so now our board is done. Watch this. However, if we didn't do this, notice right away there's an error. What do you guys think that error means? What is that error about? An uninitialized board object. That's right. We can't run this because there are, self.board is not initialized. Right? So you have to initialize all the stuff. There's no default value. This is not like null. In fact, the concept of null, which in this language is represented by nil, just like it was in Objective-C, is really different than most other languages you've worked with. So we have reference types and value types. Value types are allocated on the stack. Reference types are allocated on the heap. You can't have a null value type because you can't point null at it. In any other language, you can have a null reference type. In this language, you cannot, even though, let's say var s. I cannot say this in this language. We'll talk, if we have time, we'll talk more about this. But they took this safety thing to a whole new level and said, even pointers, things that are basically represent pointers that you can't get to the memory address of, right, like classes, cannot be null. Even to get a nullable reference type, you have to use, there's the same concept as a nullable here, the same syntax. Right, so things literally cannot be null at all unless you said, I intend for this variable to sometimes be null, which is fantastic. It means like if this thing is null checks, go away to a large degree. And there's some other interesting stuff for dealing with null. All right, so now we've got our board. Let's go back to our little main app here and see what we can do. Okay, so let's do a little print line on it. We'll say tic-tac-toe pro, or something like that. We'll do an empty print line here, okay? And then we'll do one at the end, just so you can see, done, exiting, bye. So I can run this, and down here you'll see, whoop, it's all good. Okay, so looks like everything's hanging together. Now it's time to write the game loop. So we're gonna come over here and we're gonna say, we've got our game. We need to ask while game.hasAWinner, like this. Could be like this, could be like this. Had an interesting discussion with one of the other speakers this morning that said, that is evil, this is okay. I really don't think there's a difference. But what's cool in this language, those could mean the same thing or they could be different. That is, they have properties, just like C# has properties. And you may be somewhat familiar with them, but like nullable, they take it to an insanely new level, okay? In a good way this time. Okay, so I want to know this, and then I'm going to write my while loop like that. Remember, there's no parentheses because actually we never needed them ever, just the people that wrote the compilers were lazy, didn't want to worry about parsing that, right? So we can come down here and we say, well, this needs a var has a winner. Well, turns out has a winner is kind of gross to write. So I'm going to copy something here in a minute, just on this one time. But let's think about it for a minute. Do you think has a winner should be something we could set? Just straight up. True. Yes, we have a winner. Don't know who it is, but he's awesome. You want it. No. So it could either be a function I could call, or it could be a read-only property, right? So here's how I create a read-only property in Swift. I say var has a winner, like that. Now I could say get, put some stuff, set, put some stuff, and I could return stuff here, and I could say var s equals new value. They thought value would, if they said value, it would look too much like they copied C#. So it's not new value. Otherwise, that is C#, right? But what's really cool, what they did is that, okay, that was a good idea, C# people. Thank you for that, Anders. But if it's get, if it's read-only, like, do we actually need to write get? Like, that was kind of like too much typing. So you don't need to. I could just say return false. And that's a read-only computed property. Now, I told you they took this to the extreme in like a pretty extreme way. Up here, what is this about? Computer property must have, oh, it must have an explicit type. This is true. So this is a capital B bool. That is a computed property. That is a property with a getter and setter. That is a property with a getter and setter. That is a property with a getter and setter. There are no fields that you can write in a class. Right? So instead of saying, public string thing, curly get semicolon, set semicolon, they're like, why don't you just write string thing and then we'll just do that for everybody. So at a compilation stage, it doesn't matter if I write it like this or I write it like this. It's all a function call to the getter, deep, deep down, yeah? So that's pretty cool. Everything is a property, and there's nice clean syntax for basically auto properties and these computer properties. So that seems like a pretty good way. I mean, if you're kind of pessimistic, let me go over to my iPad second monitor, which is pretty cool. Come over here. I'm going to copy two versions. No, let me copy this second version because the first one went really wrong. It actually crashed the compiler. So here's the deal. You could win going down the diagonal, or this diagonal, or you could win by going across here, across here, across here, or you could win like this, or like this, or like this. And I've thought about a nice algorithm for doing it, and the algorithm is just as long as just writing them all out. Okay? So let's just write them all out. All right, and so let's say, just to keep the typing short, we'll say var b equals board, bool, board, whatever, it's all the same. Okay? And these are the possible wins. And then notice this looks like I put a new line in here, but this is actually word wrapping. The editor does word wrapping by default. So here's a quick math question for you guys. Pop quiz. What can I do to check if I've won? If one of these is winning. What is the mathematical state of one of these little pieces if there's a winner? Remember, X's are ones, O's are minus ones. They're all the same, right? They're all either X's or they're all O's. So that means the sum is either 3 or minus 3. Right? That's why it's easy. So we can say for Wn wins, right? For each loop, we'll say if there's an interesting way to do sums, but I'm just going to do it the simple way. So var sum s equals 0 for say play in W. S plus equals play, we'll say if S equals 3, let's say like this, if ABS of S equals 3, return true. Okay. Type int does not conform to sequence. Oh, I already have the wins there, sorry. I've already added them up, I was not paying enough attention, apologize. So we've already added them, we didn't just put them in the list. So either that's 3 or minus 3, that means you win. And that should be W, thank you very much. Yeah? So if they're either 3 or minus 3, we have a winner. Pretty cool, huh? All right, so it's cool that we have a winner, except there's no way to change this, so maybe we won't win right away. Let's go back to our main here. And let's do a little bit more. But first of all, let's see who the current player is. Okay, so let's print line. Sweet. Somebody has won. And then we can go over here to our game and say game.current player. There. Now that's going to come back as either 1 or minus 1, probably. So let's say current player text, which will be computed here in a moment. All right, so let's go over here and add one more computed property, this time much simpler. We'll say var player text, which is going to be a string, and we can do something that would feel very C-sharpish. We'll say return. We want to do a test. I have no current player, so we'll say var active player equals 1. So we'll say if active player equals X, then what are we going to return? We're going to return X. Otherwise, if active player equals O, we're going to return O. Otherwise, what do we want to return here? We could return, if this was C#, maybe we would return null. But if I try to return null, it'll actually not even compile because strings, even though they're in memory on the heap, cannot be null. Right? That's how this language works. That's kind of awesome. So we're going to just put none or something like that. You really, I think actually this is probably good enough, right? I could just say, oh, there's always going to be an active player, let's say. But you can't return nil. So let's go back here to our game. We can do that by switching up here. So we can come down here. Let's do a little print line statement. It's whoever's turn, game.current player text. We'll say return, something like that. Okay? Here we go. All right, now what we need to do is get some kind of input. Notice, by the way, to use this type from over here, I didn't have to say like import or using. There's no reference to the other types. There's no real concept of namespaces either. It's just all the Swift files have access to all the other Swift files. So let me go to my desktop and root around just for a moment. I'm sorry. Let's see. I think this is the one I need. So it turns out getting input from the console is not super fantastic in Swift. So let me just copy this prompt class that I wrote because it's just not worth writing. There's no value to be gained, but I'll show it to you anyway. So I come over here, not there, to that one, and drop it. Kind of like C#, it'll copy the files locally instead of reference them far away. So if you go over to prompt, you got to go and get the ns file handle with standard input from the keyboard, da-da-da-da. Whew. Don't worry about it. We're just going to say prompt. Say var play. Let's do this. Say print line. Let's say print. What row do you want to play? Want to play. And then we're going to say var r equals, and we'll say prompt, which is the class, dot input, and that'll do like, it'll call that function basically. We want to do the same thing for the row. Now I could like have them have a more interesting, let's do it for the column. I could do something more interesting and parse it, but we're not doing that. Say R and C. And let's just run this to make sure everything's hanging together here. So if we run it, it's compiled. Sorry?
I think it should be allowed not to pass.
Oh, yes, thank you very much. You're right. Very good. It said exiting by, no, it actually had a problem. What is this problem here? Must return a bool, so return false. Luckily, I never got it to compile, so I didn't have that error. Thanks for catching. All right, so we run it. Still missing, oh. Wait a minute. All right, it didn't succeed, it succeeds. Okay, so we go down here. It says, what row do you want to play for? What column do you want to play to? Okay, and it just goes around and around. All right, so that's cool. Now let's actually start to play the game. So if we go over here to the main, we might want to somehow add a function down here, like game.play, play cell, or something like that. Row, column. And some interesting stuff is going to happen here. So let's go back to this view. It says there is no play cell function, so let's go write that. Down here. So we can say func, just like you do regular functions, to this. Then we're going to give it a name, so row, colon, that's an integer. And we're going to give it a column, colon, int. And it's going to return, let's say it returns a bool because they could have already played this. And we don't want them to be able to play like where, you know, maybe X is trying to play where O is, and you want to do that. If, you know, in C# you might make that a void. What would you do if somebody did something wrong? Exception. Yeah, we don't have that, so we don't do that here. There's just no exception support in this language at all, which is super, super unfortunate.
So no null and no exception?
You have null, you have to explicitly declare. You have to explicitly declare null as a thing you might want, that's kind of okay, but here's where it gets weird is if I've got a property, apparently I have a meeting, no, just kidding. If you have a property that you can read and write, how do you indicate that the write to the property failed? You can, one option that has like been passed around is you can fail your app, say exit app with fatal error. That's pretty excellent because you know you really did something wrong then. Don't do that again. One of the other things you can do is they say you can use the default value and then print line it to a debug message. These are your choices, basically. There's no exceptions, and it is a big oversight. But Objective-C didn't have exceptions, and so we don't want to add more runtime features to the compiler, the language, or I mean, it's about this compatibility versus new. Anyway, it's a big oversight. So we're going to return bool, and we're going to try to pretend that that's okay. All right. It may be okay, but the fact there's no exceptions is a really big problem.
What happens if we divide by 0 then?
Fatal error, application exit. I'm not entirely sure. It might just give you a weird error. But if there's an error like that, and it's literally an error, it'll just exit your application. You know when you're working on your iPad and you click something, it just goes away? Like, why did that go away? I don't know. Well, it's something like that. Like, we don't have exceptions, so we just fatally exited your app. And I believe the word is fatal error. Boom. Down she goes. Like, that's what you do. It's not killer. Okay. But what we're going to do is we're going to play this. We're going to say, we're going to try to get these rows and columns. I should be doing validation that they're within 0 to 2, but just roll with me here. Var cell equals board of row of column. That's how this works. We'll say if cell is not equal to empty, return false. Okay. I'm already feeling better not typing semicolons. I just want to let you guys all know. Okay, and then I'll say, all right, so if that was good, if we made it past this, then we're going to set that equal to self.current player, active player. And while I'm down here, let's write another one, func swap players. That can be void void, so it looks like this. It looks like, let me make that bigger, higher. Self.active player star equals -1. Right? 1 -1, 1 -1, 1 -1. Good. This is actually unhappy still. Good? Good. Okay, so let's go back to our game here. We want to do this play cell, but we should check. We should say, if not, we might want to print some kind of error message. Whoa, that didn't work. Didn't work. Didn't work. Try again. And notice there's like this little grayed out thing for the complete the string, but if I move over, it'll kind of just type it in for me. That's cool. And then I'll say continue. Just like every other language, that's how you continue in a while loop. All right, but if it did work, then let's say game.swap, we'll say this. We'll say if not game.hasWinner, then we need to say game.swap players. Swap, spelling hard. What did I write over there? Something wrong. Okay. We might be able to play this now. You guys want to try? It's going to be awesome. It's going to be the most amazing. We could not find. What is this? Return. All right. What are you not happy about? That accepts supplied arguments. All right. What does it think that's doing? You can command click it. That's pretty cool. I just think it's not defined. Game.
Maybe it's on public?
No, because these are all public. It's the default. It's, I think internal is the default. Oh, I know what it is. So if I go down here and I type game dot, there's a play cell, but notice what the completion is doing here. My C# was showing through, I'm sorry. So I come down here and I hit tab and it fills out. So okay, the first thing I'm going to put is column, like that, and I hit tab, and notice it didn't remove the other ones. Okay, so I'm going to put the column there. That's what I need to do. So the language stuff is really interesting here. I think that's what it was complaining about. String is not convertible. Oh, maybe I'm returning something wrong there.
What do you read from the command line? Maybe it's a string with not.
Oh, yeah, that's right. So thank you. So I wanted to leave that as an error, but then I forgot I did that. So this actually comes back as a string, obviously. This is a highly compiled language. Think like C. It's not just going to take a string and go, oh, that looks like, it's not like JavaScript. It's like, oh, that string probably could be an integer just as good as the next one, you know? So we need to convert it. And the way you convert this is you would say int and pass, like basically call the initializer or a constructor.
And what happens if it's not an
then it
No
will crash.
exceptions and no problems.
Yeah, then it'll crash. What is wrong with my int here as well? All right. Yeah, that's, I mean, exactly. What happens if there's a problem with a constructor? What are you telling me? Cannot invoke init with argument of type. Oh, no, sorry, I have it backwards. I need to call on here. There's, so actually, no, this is a really interesting case. So that you say toInt.
Like, will it return 0? Or
No, this one,
doesn't
this
make
is actually
sense?
okay. So this is okay. Watch this. So I come over to the help and I can click on this, and it shows, and this font's way too small for you guys to see. It returns a nullable int, which is a perfectly legitimately good thing to do. Yes? Yes. But that's why it's not the constructor. Sorry. My next talk is in Python, and that's how you do it in Python. Anyway, so let's look at this for a minute. How do we test? Well, I could say if r = nil, then this is the problem. All right? Just like C#, you would say if it's null, it has a problem. But they have this really cool syntax. There's two types of cool syntax here. There's a way to write this all as one expression, and I can say if, basically this. If I can do this, I'm going to work with it. And it takes a thing that's nullable on the right and puts it into a non-nullable version here, else print line bad number, try again, continue, okay? Except for this should be the keyword let. And let is like a variable that is constant. Not just a variable that is constant, but a thing which its entirety is constant. So if this was like a struct, say, not only can I not change what it points at, but I can't go like down the object graph and change anything at all within it. The whole object has become immutable, right? But in this case, it's just an int, so it doesn't matter. So I could write this. Now it's kind of silly because there's nothing in the if clause, but you'll see there are cases where this is really cool. You know, I've got 22 minutes. I probably won't be able to show them to you. There's another thing I could do to say, I'm really confident that the user is going to get this right. I could say exclamation mark here on the second one. And that just means cast it to a non-nullable int. And it usually works if the user comes down here and types something, unresolved identifier, oh yeah. So I need to basically put this stuff is only defined within this little area. So let's just do like this again. So let me just put the exclamation mark here as well, right? Just to keep this simpler. But I move that bit inside like a nested if statement. All right, so if this works fine, you guys who are laughing about the constructor, build succeeded, okay. Or the lack of exceptions were like this. So if I come in here and go, what row do you want to play? 22 and 11. Oh, sorry, yeah. So there's no exceptions, it just stops, right? So it would do the same thing if I typed in like the word cat down here. And it couldn't parse it. If I say cat, fatal error, unexpected nil found by unwrapping optional value. Right? There's no exceptions, it's just dead. It's dead, Jim. Okay? So you probably don't want to do this. You would like to test if it's equal to null or not. Okay, but just to keep it going for time, we'll leave it like this. So I'm going to just type things that are within the right bounds. The last thing we need to do is we need to print out the board so you guys can see it. Just for the sake of time, let me go rob this from another section. I want to open it in Xcode, I guess. Thank you. So what I'm going to do is create a read-only property. You know how you override toString in .NET? You have a function, you say the keyword override, it returns a string. Here we have what are called protocols, which are like interfaces, and one of them is printable. And if you implement the printable interface and somebody like basically calls toString on you, it's going to return for the value whatever the description computed property is. Okay. So let's go over here to our game and say our game is printable and it has a description at the bottom. And There's the description. It's not hard, it's just not super, super fast to write. I want to build an iOS app as well for you guys. So let's roll with this. So let's go down every step of the way. Let's print out our little board. And let's say print game, print line game. And let's do another print line just for some space. Okay. So if we run it, let's move that up a little bit. It's compiling, hang in there. Something going on really bizarro with my computer. Build succeeded. Okay, cool. So you guys see, we got our tic-tac-toe. This is what you were dreaming of when you thought of an iOS app, right? It's beautiful. No, just a minute, we'll make this an iOS app. Okay, what row do you want to play? 0, 0. Ooh, there's an X. Sweet. All right, let's play. Now it's O's turn. They're like, there's no way you didn't go for the diagonal. All right, let's say 0, 1. And they're like, oh yeah, I got this covered. 2, 0. 0, 2. Woohoo! All right, cool. So that was hopefully a good exposure to the language, if not the most desirable iOS app you've created. So let's do that instead. Let's say File New Project. And now let's go over here to Application, iOS, which is what you all thought this talk would be about, right? So we'll create a new iOS app now that we know about the language. And it's basically the same as before, but there's a few things we want to work with. Make sure, by default, it looks like this. It's unlikely what you're looking for. You probably want that on new app, on new projects going forward. We'll call this DevWeek tic-tac-toe. All right. Now, we could say universal. I'm just going to keep it one super simple design. We'll probably saw Mark's excellent presentation on adaptive layout. We're going to just put this on my desktop. I'm going to put all this on GitHub for you guys. You can take it with you, like, do whatever you want with it. All right, so we get more stuff when we create one of these. How many of you guys have created an iOS app, at least like this step? Awesome, so most of you, cool. There's one hand up for you guys in the front. So over here, can I get to the side? Not really, whatever. So you've got your app delegate, you've got your view controller. So the two parts you care most about are main storyboard, which are like, is your design surface, and the view controller, which is sort of the behavior behind your design surface. So let's do a little design bit first. Actually, let me go over here really quick to, is this the one I created? I think it is. So if we copy this, let's just throw our game in here so we'll have our game to work with. Luckily, we won't need prompt anymore because we're going to have a proper UI. Okay. So here's the game that we just wrote. And we're going to use this in our little app now. So I'm going to go to the storyboard. And I'm going to go down here. And I have a label. And I'll do a little tiny bit of design for you. And then I'm just going to throw stuff on here. So I'm going to go up here. I'm going to say, first, let's make this bigger. So let's go down here and say this is 32. And let's do something cool like this. Let's go over here and say this is going to kind of be most the size. And it's going to have this text like tic-tac-toe from DevWeek, like so. And maybe we want it to arrange in the center, like so. See, here's the little top thing with the, what do you call it, with like the bar that's always up there, you know, the battery and whatnot. So we'll put it like this. Now if I run this, let's not run it in the silver iPad, which is awesome because that's what I named my iPad because it's silver. But let's run it in one of these little pieces here. So I'll run it on iPhone 4. Run it. Remember I told the center, it's right in the center, it's super awesome. This is the part where you wait. You see stuff is happening up here. It's building, compiling, it's almost there. Kicking off the simulator and survey says, it's down there. Tic-tac-toe, almost there. Oh, it's over. So this little designer, you got to do some stuff with, it's called auto layout. Right? We're not going to do very much with auto layout. We'll do a little bit. So I come over here and I can, it's control drag to the container and say, I want you, oh no, I want to do it this way. I want this thing, this little label to be connected to this. And I would like it to be the leading space and the trailing space. So connect that side to the leading space. I think if I go over here and drag it again, I can get to the trailing space. Now I've got this. Now if we run it again, really quick. It's not big enough. I should make the font smaller, but you can see it's there. Right? So cool. Let's go back over here to our storyboard, and let's make that font a little smaller. I kind of got ahead of myself with that huge size. Let's say 24, and let's go over here and make the color yellow, because yellow is awesome. And let's make the background color of this, which is by default empty, we'll make it black. Then over here, let's go to this thing and make its background color like a dark, it's a light gray. Okay, we're all good. Now, the next thing I want to put over here is I want to put, okay, I want that to go away and I want that to go away. The next thing I'm going to put over here is I want to put some buttons on there. And I kind of want to be able to lay them out and not do all the work for the auto layout and class, size classes and stuff that Mark talked about. You can watch his video, that's pretty awesome. So what I'm going to do is I'm going to click this little double circle thing up here that's called the Assistant Editor. And normally it lets you get to your code behind, if you will. And instead, I'm going to go here and say, pull this down to this preview. And here I have a 4-inch iPad. And so this will show me how things really look over here. So let's just go over here and put some buttons. I'm going to put one button on there that goes here. It's cool, you can see it over here. Let's make this button bigger, like this. And change just a few things about it. Its text color is going to be white. Its background color, which is nowhere near the text color, totally makes sense. Perfect, that's how it should be. It's over there. Let's make its fonts bigger. Its fonts are too small. Let's put 24. And you know, button is interesting. It tells you it's a button, but let's just go with like X or something like this, okay? Now notice where this layout is here. So I'm just gonna like really quickly throw these together and see if this size is all right. It's too big, hold on. Let's go like that. Just because we have now very little time, like this. Notice where it is on the right. We should be using adaptive layout, but I'm not. Sorry, Mark, I apologize. Click on those, copy, paste, down they go, paste, down they go. Let's add one more label down here, and here this label is going to be, it's going to be like, you guys are so awesome, the X is 1, something like that. So it's going to go like this, and let's say winner text. Okay, and again, let's center that, and we can make it bigger so you can see it in the back. Okay, so now let's go back, not the preview, but to our automatic piece here, which shows our view controller. So I suspect most of you have not seen what I'm about to do if you've not gone to Xcode and created one of these. Yeah? So in .NET, I could open this up and it would be WPF or Windows Forms. It would have, I could click on something and have some properties, and I could change their name, and they automatically get added as to like the code behind. And then they have events, I can hook the events. It doesn't quite work that way here. You have these things called outlets, which are like variables or properties, so you can access the data. Kind of like in WPF, you have to name the element before it shows up in your code behind. Here, you have to click, drag, and do a thing. And then for the actions, you do a similar thing. So the way either of them work is you come over here and you click and drag, and you let go. And it says, do you want to create an outlet or an action? Let's create some outlets. I'll call this, I'm going to be super creative. This is going to be button 1-1 because it's in the 1-1 position in my grid. All right, so come over here. Let me just do this for a few times. Button 1-2. In fact, I will do this 9 times. It's going to be awesome. Put it up here. Button 1-3. Dun, dun, dun. Let's keep naming them. Button 2-1. Button 2-2. Now, in reality, I'd probably put this in a better order, but just for the sake of speed, I'm just
Can
gonna.
you copy and paste? I mean, just the text.
No. Like I can do it. Yeah. See, this is kind of awesome. Okay. As in not awesome. 3-1 is what I want, yeah? Notice right here, hold on, it's okay. See these little things, these little circles? As I move over them, they're like interacting with the UI. These are called the outlets, okay? And if I want to make another one, I could even do some action like that, right? But this one, there is none, right? No, I can't. Wait, hold on. If I go like that, I could do it this way, but it's honestly just as quick to do it this way.
Okay.
Yeah, okay. I'm telling you, you guys have been spoiled. You've been in Visual Studio, man. Let's go write some C code with like GCC for a while. We'll feel better about it. Okay, so now we've got all of our buttons. Let's get rid of this assistant editor for a minute. Oh, hold on. No, we need one more while I'm here. Let's just get this all done at once. So those give me the properties to interact with the string values like the title and so on. But what if I want to click it? Now this is a less bad story. So if I click one of these, I'll do the same thing, but I'll create, instead of an outlet, I'll create an action. And I'll say I want this to be a button, not just any object, but a button. And this will be play clicked, okay? This, you can see a function. Notice up here the week keyword, right? All right, so here's my function, and I can do this. If I click here, you can see which one lights up, but I also want this one to be a part of that one, and this one to be part of that one. Now you could highlight them all and drag them over here, and it will kind of look like it worked, but it only does the last one. But at least this is better, right? All of these buttons, no, go away. All of these buttons are gonna be this one. Hang in there, and so it says done. And while we're at it, let's just put our winner text over here. Winner text, okay. So now if I click on this, you can see they all light up. Yeah? Good? Okay, let's put away our assistant editor. We should be able to just go back to the UI, which is here, and work with it. So when somebody clicks a button, we don't know which button it is. Let me make this taller for you. We don't know which button that is. So let me get an easier way to work with buttons than just this nasty numbered thing. So we'll say var buttons. This is going to be an array of all the various buttons. So it's going to be an array of these, what are called forced unwrapped nullable types. It's going to be an array of those. Now, it's actually easier to know where to play on the board if it's an array of them. There's 3 over and so on. So it's the same shape. All right, and so now we're going to come down here and initialize this. We're going to say buttons equals. I'm going to do an array, and then just like I did before, I'm going to say, this is so much fun, watch this. See how cool that is? I just get to type so much. Okay, so we're going to come down here and make this 222, 222, and 333. There, now we have our buttons, and button D is not exactly what it's after. Buttons with an S is actually what it's after. Make sense? Now let me show you something that's totally awesome. I would like to know, when I click one, what button was clicked. So let's do this. Let's say, well, like a var thing equals get clicked, get row and column for the sender. So I'm going to go through my button list and see which one that one actually matches. Okay. So it turns out that this needs to be a function down here. Func that. It's going to take a b colon UI button here like that. And we're going to say for each loop, right? For row in buttons, for b in row, if b is equal to, hold on, if it's equal to the button we're after, then we're going to return what? I want the index of those two things, yeah? So maybe I need to go back and say, forget this. We don't have enough information here to work. You know, I got to switch this to an indexed for loop. This is where the Python comes in. So in Python, there's a super awesome thing. You say enumerate, and what it's going to return, you pass it a sequence, and it returns a tuple of the index in the sequence. But then you can do what's called decomposing the tuple back into individual variables. So I can come over here and say, well, index r, comma, row. So I'm declaring two variables, which the first one is the first value of the tuple, the second one is the second value of the tuple. They're individual variables. That's not a tuple that I'm basically saying the shape that you're going to put into is this. The first one is called the first thing, second. And then down here, I can do the same thing. I can say index column, comma, b in enumerate R. Yeah, like so. And then if it's even, we'll just say return a new one. Typing has seemed to have stopped. Hold on, that's not good. Yeah, it's kind of a new technology, so let me restart it. It's just the IntelliSense crashed literally. DevWeek, I think that's the one I'm looking for. Nothing happened. It's all good. Okay, so we're going to return another tuple that's index row, index column. Right? Instead of having to create a new type, I can just say over here. Well, I need to tell it, it's saying, whoa, 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 you're void right now. There's no return value. So I say you're going to return a tuple that is an integer and an integer. And I can do this same trick up here. I can say let row comma column equal that. Now I have a thing that's called a row and a thing that's called column, and I can use that to play the game. So I can just say game.play. Where's my game? It's up here, right? No, I haven't created it. So let's come over here and say var game equals game, right? It seems unhappy, but
It should be a nullable tuple?
yes, it probably should. It should be a nullable tuple if like they.
'Cause
Well,
you might not return anything, and then what happens?
one of the buttons is clicked. Yeah, but one of the buttons is clicked. So long as the UI is in sync with it, then it should be okay.
Yeah, of course, but I mean,
It probably-
compiler-wise,
Yes, compiler-wise, it should be a nullable. Yeah. So I can say play cell R. Then here for this, I put C. Okay. Let me write one more function really quick, which we're going to need all the time. Let's just say game.swap players really quick, because most of the time we'll want to say this. We'll say if this worked, we want to swap players, but if it didn't work, we somehow just don't want to do that, right? If they try to play the wrong cell. And let's write one more function, sync game to UI. Okay. Super creative name. So we'll say func that. And down here, let's use this thing again. We'll say for bin buttons. We'll say basically the same thing. Here. That's so great. Sorry about that. Okay, so we're going to say this, but we're going to use B. So then I want to write one more function for the game. So I want to say set the title here on this, on the buttons. And it's going to be some sort of title I want to get. So I want to go to the game and say game get cell text. All right, we're going to write that function, and it's going to have a row and a column. So last thing, and this is going to need to be externally named, as they call it. Let's go over to the game, write this function.
Can you not have current player text?
What's that?
Current player text?
No, because this is what's play. It's not the current player. It's who previously played that cell. Yeah. Func. This is going to go to a string, and this I should be able to just. We'll say var C equals board, and again validation might be good here. This is going to be int, and this is going to be C. We'll say return something like this. Could be 2 more minutes and we'll probably be done. If not, then it'll be a few more minutes. It won't be too much longer. Now maybe I would return nil here, but just for expediency's sake, let me just put like an empty placeholder. Okay. So last thing, we need to start out our game with it being synced. So here's our sync UI buttons. Let's call this like right in the view did load bit, which is up here, like kind of the view is on the screen. So let's run this. Fingers crossed. It may or may not hang together. There's many little warnings over here, but it also may be running. I'm not sure. Build failed. Okay. Has no initializers. Hold on. Let's go down here. Yes, yes, yes. Oh, hold on. Game Required initializer init coder. Oh, must be provided by subclass. Will it fix this? So it wants me to create an initializer. Let's see. Init this. Now what is that? Sorry. Now it's over here.
So just the order?
What's that?
The order, if you move the decoration of the property downwards.
I don't think so. I don't think that's going to be okay. So I don't know why this is. Hold on. Let me just, because we're kind of in a hurry, let me look at and see what's in this one I wrote 10 minutes ago. That's awesome. Thanks. No. Well, you might be right about that, actually. Yeah, you're right, because down here. Required initializer coder. And let's try this. Init coder. X-ray. There's no subtype. Get row and column B. Yeah, there's something going terribly wrong here. So, alright, so since I'm over time, let me just open the other one, I'm sorry. But it really is the same thing, basically. Then if you care later, I'll make it work, you guys can watch. So this is the same basic thing. If we go over here, let me just run this. So we go over here, now we're gonna click. Alright, so you can see it's swapping the players. And of course, doom, we have a winner. Nice. Why? There's no initializer that wants to run my class. But literally, there's no changes from those codes. So, other than the view is happy. Pretty cool, right? Now, we didn't do a very good job with our layout. We probably should do that. Mark will let me get away with it, I'm sure. Final questions? First of all, it's kind of overtime, so let me just say thank you for coming. If you guys want to scat, that's okay. Appreciate it. Now, final questions? What do you guys think of the language? Yes? No? Like kind of sideways? Like yes and no? It's really different, right?
I'm upset about the exception.
I'm upset about the exceptions as well. You want to see if I can make up the exceptions? So suppose I had this. I had x, which is int nullable. Let's say var g, which is a game nullable, and so on. You can come down here.
If I end up making everything nullable,
Then it's okay. Well, but what I want to show you is you can come down here and you say things like this. You can say, instead of force unwrapping these to get like play cell and so on, you can do what C#6 has, coming, game question mark dot play, and that returns a nullable. And you can do this optional chaining, which is really sweet. But you still don't have exceptions, which I also miss. Cool. All right, let's see if the internet works now. I'll show you where you guys can get this straight away. It wasn't super happy before.
You mentioned the, was it the JetBrains tool?
App code, yeah.
Is it, is that,
Cheers, thanks.
is that better?
It's
environment?
better and worse. The UI stuff just goes wrong if you try to use, but the code part is better. So let me unplug this and try one more time. No, the internet is toast. Anyway, let's try this. Let's try this way. Go here, right click, open with, app code. One thing that makes it better is it's black, which is awesome. Because this white stuff is just, I don't know, it's not good on my eyes. It's pretty cool. So I come over here and I go to my game, for example. And you can just do, there's a way to zoom this. But, you know, it's just, I don't know, as you interact with it, just everything works a little bit nicer. It's like indexing a whole bunch of stuff. You can see built-in symbols, so that's why there's no color coding yet. Give it a moment.
The usual creates classes for you.
Yeah, all the resharper stuff is over here.
Yeah.
So if I'm writing in the code stuff, I'm very happy to throw it into app code and use that. They might have different hotkeys because it's on Mac, but they basically have the same resharper hotkeys and refactoring, all that stuff. That's awesome. But do not do like the UI stuff here. It can just shred your UI and like not put
There's
it
no
back.
syntax highlighting.
It's see this little bottom bit where it's still building the IntelliSense stuff. So give it a moment and then you'll see. Yeah, it's starting to come in a little maybe. No, not yet.
But is that only about Swift or any other language?
It also does Objective-C. Yep. There you go. Woo! Nice color. And so I can come down here and do things like this, like self.run or whatever that means. It's like, oh, there's I believe, will it give me the problem? Maybe the run is a thing I can do. Give it a minute. Oh yeah, it's thinking now. That's one of the features of the JetBrains products. They don't let you like jump into stuff like too much. You're like, okay, just get yourself in the zone. We're just gonna wait. Okay, there we go. Now we're prepared to do something with this thing. And I don't know if it'll actually do it or not, but it's just, trust me, like the typing experience, like duplicate line, and there's just a much nicer set of like text editor stuff here. But the UI, not so much. All right, other questions, comments?
I understand that the language is quite popular, right? I mean, the book that you show, but is there many applications, production applications?
Apps that are in the App Store?
Yeah.
You can't really tell by looking at them, so I don't know for sure, but I think I was reading about, I can't remember which one it was, but some really popular one or two that got in there. I don't think a ton of them are, but it has been out since September, so I'm sure there are plenty in there. Mark, do you have any? You know the ones that are Xamarin that are awesome, right? But not the ones that are Swift, yeah. Yeah, so I don't really know. There's no way to look at the compiled output and know, which is kind of a feature of the really tight
Well,
compatibility.
that's quite good actually, but
Yeah.
I see that especially the compiler and all the errors that
Oh yeah, it's totally flaky. It's super flaky.
we need to wait a little bit.
Or use app code. App code's pretty awesome.
Don't want to wait.
Yeah, exactly. I mean, it seems like all the errors I've run into with it, it's like just restart it and it works again. You know, I think of like when they switched Visual Studio to WPF or something like that. You know, like 2010, like this thing's breaking all the time. You know, well, I don't know. Right? It's just a new piece of complex software. But trust me, the alternative to do native stuff is Objective-C. I'd rather have flaky code and write it in Swift than have super solid Objective-C tools. You know, no thank you.
I can't.
Yeah.
Is there anything you can't do in Swift that you can do in Objective-C?
Anything you can't do. Well, the Objective-C stuff is dynamic, so you can do like more maybe runtime stuff, whereas this is a fully static language.
Yeah, introspection's not really there yet.
Yeah, I mean, you can get a hold of the type. It's like even printing out, like giving it like a what's called an any object, which is like low, you know, it's just like a base thing. It's super hard to even know what type you were passed. There's not a lot of that kind of support. In Objective-C, it just kind of doesn't matter.
But the nice thing is you can interoperate from Swift to Objective-C. So if you run into those edge cases where it's not available, you can just add in Objective-C into your project and call it.
Right, just add like a utils function in
Yeah.
Objective-C and then just pass it on and get it back and then keep going. Yeah, absolutely. And there's not much you have to do. Like watch this. If I go back to my Xcode project, let me go to the one that I'll give to you. That one that's crappy for some reason. And I'll say over here and I say add new file, and I pick Objective-C, I hit go, test, and it says right here, it says, okay. It looks like you're starting to cross over into this land of like heterogeneous stuff. Would you like to create a bridging header that will allow you to seamlessly use the two worlds together? And so it'll generate an Objective-C layer that you can basically define the classes and the function signatures from your Swift stuff and then vice versa. Right, so it's pretty easy to do what Mark is describing. Actually, we don't want to do that. It's like, it is not a bad language, you guys. it's not quite as good as .NET, and so one consideration is maybe you'd use Xamarin tools, right? But this is like fully native Mac stuff, and it's free, which is also a nice feature, right? Go to the App Store, search for Xcode, download, you have it, right? It's free once you pay $4,000 for the laptop, but we just like, yeah, whatever, that's free now. Thanks for that. It's like go to a 5-star hotel and oh look, the soap is free, fantastic. But
There is nothing for free.
exactly. You just pay up front. Think of it as prepaid. Let's say it that way. It's prepaid. All right. So thank you so much. Appreciate you guys coming, waiting long.